You know that jar of honey that's been sitting in the back of your cabinet forever? We've all got one. And you've probably noticed it looks exactly the same as the day you bought it. So, have you ever stopped to wonder why? What is it about this golden liquid that makes it seem like it can last forever? Well, today we're going to dive into the incredible science behind eternal honey. Just let that sink in for a second. 3,000 years. That's older than the Roman Empire. We're talking about food from a pharaoh's tomb that you could, in theory, still spread on your toast this morning. I mean, that's not just a cool fact, it's a legitimate scientific puzzle. So yeah, the big question is, how is that even possible? What kind of magic is going on inside that jar that makes honey immune to time? Turns out it's not magic at all. It's a brilliant combination of chemistry and biology, all perfectly engineered by nature's master chemists, the honeybees. Let's break it down. All right, let's start with that amazing discovery. Imagine being one of those archaeologists cracking open a sealed pot from an ancient Egyptian tomb, and inside, you don't find dust or decay. You find honey, still sticky, still sweet, and perfectly preserved. This single discovery really kickstarted the quest to figure out what makes honey this one-of-a-kind eternal food. As it turns out, there isn't just one secret to honey's longevity. It's actually a few key things working together in perfect harmony. And the first one, which is arguably the most important, is what I like to call its dry defense. At its heart, honey is basically a super-saturated sugar solution. But the key is this: it has almost no water in it. Think about other foods, fruits, vegetables, meat. They are all loaded with water. And all that moisture, it's basically an open invitation for bacteria and mold to show up and have a party. Honey, on the other hand, is like a desert. In fact, honey's water content is incredibly low. It hovers at just around 17%. To give you some perspective, a fresh apple is over 80% water. So this super low moisture level makes honey an unbelievably hostile place for anything that might try to grow in it. So what exactly happens to any unwanted guests, like bacteria? Well, microbes need water to live. It's non-negotiable for them. So when a tiny microbe lands in honey, a process called osmosis kicks into high gear. The super high concentration of sugar in the honey literally sucks the water right out of the microbe cells. It essentially dehydrates them from the inside out. It's a brutal, effective defense. But being incredibly dry is only part one of honey's super secure defense system. Nature gave it a fantastic backup plan. Let's look at the next piece of the puzzle, honey's second secret weapon, its acidity. So, on top of being a desert, honey is also naturally very acidic. This adds another powerful layer of protection, creating an environment where very few organisms can even think about surviving, let alone spoiling the honey. Its typical pH level is somewhere between 3 and 4. Now, for a quick high school chemistry refresher, a pH of 7 is neutral, like water. Anything below that is acidic, so a pH of 3 to 4 is pretty far down the scale. But just how acidic are we talking about here? Well, this chart really puts it into perspective. Look where honey is on this scale. It's right down there with things like lemon juice and tomato juice. It's way more acidic than something close to neutral, like milk. This acidity creates yet another barrier that most microbes just can't handle. So we've got a dry environment, and it's acidic. You'd think that would be enough, right? Well, there's one more incredible piece to this puzzle, and it comes directly from the creators themselves. A secret ingredient the bees add that makes honey's defense system nearly bulletproof. Okay, this is really cool. When bees are turning nectar into honey, they add a special enzyme from their stomachs called glucose oxidase. This enzyme sets off a chemical reaction that creates small but very effective amounts of hydrogen peroxide. And yes, that's the same stuff we use as an antiseptic. It's just one more layer of stay away for any bacteria. So let's put it all together. The bees are just absolute masters of food preservation. First, they add their special enzyme to the nectar. Then, they work together, fanning the nectar with their wings to evaporate almost all the water out. What's left is this super dry, acidic, and antibacterial liquid that they then seal up perfectly in their wax honeycombs. But there is one final, crucial detail that explains why those ancient Egyptian tombs were so important. Honey is what's called hygroscopic. It's a fancy word, but it just means it loves to suck up water from the air around it. So if you left a jar of honey open, it would eventually pull in enough moisture to dilute itself, and then it could spoil. That's why the airtight seal, whether it's a bee's honeycomb or a jar in your pantry, is absolutely critical.
So when you combine all these incredible properties, what you get is a substance that seems almost perfectly designed to last forever. It really is honey's eternal legacy.
It's really this amazing three-pronged attack that makes honey so special. It doesn't have just one thing going for it. It has three powerful preservative qualities that all reinforce each other. You've got the low water content that starves microbes, the high acidity that they can't tolerate, and the bees' own enzymes that act as an extra defense. It's basically nature's perfect preservative. You know, the science of honey is just an incredible reminder that nature is often the most brilliant engineer out there. And it really makes you wonder, if this perfect preservative was engineered by bees thousands of years ago, what other amazing secrets are hidden in the natural world, just waiting for us to figure them out?